Okay, so we're trying to explore this data in a bit more detail. And one way to do that is using a technique called a radar plot or a spider plot. Radar plots or spider plots, they're called that because they look like a bit like the radars that you would see in I don't know, airplanes or submarines or something. I'm just thinking of movies I've seen, or they look a bit like spiders' webs. And the way that these things work is that you set out the normalized variables. So it has to be, again, the data has to be normalized, otherwise the very big ones squash the small ones down to nothing. You set them out around a circle, plot the values with the center of the circle as 0 and the circumference as 1, and then you join the dots to create a shape. So that's a spider plot or a radar plot. Okay, so you can see it's telling us, if I'm looking at product A, it's telling us that the sales of product A are near 1. So this is a relative to all the other products. Remember, this is normalized data, so we're talking about in comparison with all the others. At product A is one of the highest selling. Well, we knew that already. But in terms of marketing, it's only about, what's that, about there's 0.2, there's 0.4, so this is about 0.5. So it's only, in terms of marketing, it only has about half the maximum marketing of any product. In terms of the cost, it's only about 30% of the cost of anything. So when I say 30%, you can see each of these inner circles represents 0.2, 0.4, 0.6. So this circle that I'm highlighting here is about 40%. So you can see the price is about 40% of the maximum price, and the profit is about getting close to about looks like about 12% of the maximum profit. So that gives you a sense of what the different variables are for this particular product. And the order of variables, how I lay them out around the circle, can be important. And what I've done here, I set this out deliberately so that I've put the positive things that the company might want to maximize at the top of the radar plot. So the company might want to maximize their profit, okay, and they might want to maximize the sales. They're trying to sell things, they might want more money, or they might want to sell more things. I've put the negative measures at the bottom. Okay, so marketing obviously is an expense, so that goes at the bottom. Cost, that's how much they pay for the products, that's an expense as well, that goes at the bottom. Then I've put the price in the middle, because that's neither really. It's neither positive or negative. You can say that the price could be important. It's dependent on the profit and the cost. So maybe a high price is a good thing, or maybe it's a bad thing. If it's a high price, that means probably more profit, but it might be a high price because there's more cost. I've also divided it left and right. Okay, so I mean, you can't always do this with data sets. I have to say this, but with this particular data set, it's easy to do. So left and right. If you look on the left-hand side of the spider plot, the sales and the marketing. Actually, no. Let's look on the right. That's what my bullet point is saying. So the per unit values, the profit, price, and cost, those are all expressed in terms of pounds. Up to about £50 price, up to about 25 cost, something like that. Those are all on the right-hand side of the plot, whereas the total measures, the total over the year. So this is per unit on the right-hand side. Over the year, the total sales and the total marketing are on the left-hand side. So I'm dividing my plot into essentially 4 different areas, or 2 merged, 4 areas, 1, 2, left and right, 3 and 4, and so the overlap is, the overlap of total measures with positive things are in this top left quadrant. The point of doing this, why would you do this? It means you can identify easily more desirable shapes. So you can imagine if they're trying to maximize things at the top, then if we see a shape like this blue shape, where most of the shape is at the top, then that's a more desirable shape because it's got high sales, high profit. If most of the shape is at the bottom, then that's a less desirable shape because they're spending a lot on marketing and they're spending a lot on buying the product in. So it helps to identify what are the valuable, what are the most desirable products in this context, and then we can do comparisons by looking at just comparing the shapes by looking at using subplots, i.e. faceting, or we can actually overlay one thing on top of the other. So let's see that. First of all, let's see the code to create subplots for all the products. Okay, so this is first of all, in order to do this, you have to. It's not immediately set up for it inside Matplotlib, so you have to do some calculations. Okay, so first of all, we calculate the number of attributes. Well, going back to our picture, there's 5 attributes, right? That's the number of columns that we're dealing with. So we take the length of the columns, and then we calculate the angles. So the angles being, how much we have to move around the radar plot. What's this angle here between profit and price, and what's the angle here? It's 360 divided by however many variables we have. Okay. Then we calculate a list of values for each product, and we normalize that, it's already normalized, and then we add the last one onto the end of the list. That's just so that when we create this shape, the shape connects up. Okay, and then we do what's called a polar plot. So it's this line here does a polar plot, a circular one, and that's the result we get. Now, I don't want you to spend too much time worrying about this code. It's pretty standard for this kind of chart. If you take your data and you're looking at doing columns, columns as being the number of attributes around the circle, and the index, the number of rows, as being the number of plots you get, then you'll find you'll get something like this. It should work fine. Okay, so then it's reasonably easy to compare shapes. So, for example, we can see, what did he say? We wanted to find shapes where most of the information, most of the shape is above the line. So if you look at, for example, this one here, L, there's quite a lot of the shape is above the line, as compared with this one here. I'm sure you can't read those letters, but I can see that I can just about see that that's K. Almost everything is below the line. So L is a much more desirable shape than K. Whereas if we look at something like, oh yeah, there we go, C, almost everything is below the line. So that's a much less desirable shape. Same with D. But if you look at, I don't know, trying to find a really good one. There's a good one. This one here, which is R. Oh yeah, that's there's a very high profit there, but very low marketing. So you can just about make out shapes, and you can tell things, but there's still a bit too much information there. Okay, so if we want to restrict that to just high volume products, then there's actually very few changes we need to make. In this one, what I've done is I'm filling in the shapes, so I can use sub.fill to fill in the shapes, but I want them to be transparent. I don't want them to be completely filled in entirely. So I'm going to use alpha is 0.1. Alpha is used to refer to transparency, and also because I'm only in this one, I can't really put the tick marks on. So that's the inner circles, like we saw on the first chart. So there you can see these 0.2, 0.4, those are the tick marks. I can't put them on this chart, it's just too tiny. But on this one, I can put them on because I've got a bit more space, so I can set the tick marks accordingly. And that's what I get when I compare just the high value products. So sorry, high volume products. So product A, F, and L. You can see that although A and F are selling more, their sales are much higher than L. Actually, because L's profit is so much higher, that pushes the shape is much bigger on above the axis. So actually, L might be, for the company, from the company's perspective in terms of making money, the profit from that is much higher. So L might be a much more attractive product for the company, but they're not spending anything on marketing it. So this immediately this chart is giving me some information about the data. The third way to do that is to overlay them. So rather than looking at them, trying to compare them like this, I can take those three charts and plot them one on top of the other. And this again uses almost the same code as before, but there's a slight difference. I'm setting the colors here, so this is just blue, green, and red. You could and you can extend this list to have more colors, and then I have to tell it when it draws the plots what colors to use for each plot. So most of the changes there just involve using colors, and the other change is that we only create one plot. So what we're doing here, just trying to see it. Yes, we only have one subplot. So we could do this. We don't have to do this with subplotting code, but I've done it like this because it minimizes the changes between this bit of code and the previous one. So strictly speaking, I don't need subplots at all because we've only got one of them. But then I can, just use the same code as previously to get this overlaid effect. Okay, so for the overlay, that's what it looks like. And again, that makes it very clear that product L is more attractive in a lot of ways because the profit is so high. So although the sales are low, the profit's high, but it might be worth spending some more money marketing L. Okay, I'm going to finish this video there. That's radar plots. We'll now look at doing a thing called a parallelogram in the next video.